All right. Hey, everyone. Welcome to another Common Lisp study group. I'm your host, Ron Batum with Atlanta Functional Programming. We resolved our technical difficulties from last episode, so we're back in full well. Today, we will be discussing Chapter 3, which is a fairly involved chapter because it's actually going through the some pretty involved examples of extending the Common Lisp language, or the portion of the Metaobject protocol that allows you to essentially modify portions of the language at different layers in a way that would give you the ability to provide some specialized functionality based on your application needs or your system needs. The book calls these facilities the intercessory facilities, which, according to the book, and I'll quote this, it provides certain key aspects of the language implementation under the control of documented generic functions, thereby developing a object-oriented protocol for the full language implementation, which allows us to use the standard object-oriented techniques of subclassing and specialization to create what the authors call specialized languages and specialized implementations for different things. Now, a lot of this wording really boils down to something very, very simple, which is we can use, with the Metaobject protocol, just a simple subclass specialization to create what we would consider to be extended functionality of the Common Lisp system to provide system-level functions that we kind of expect a given application to have in order for us to develop applications using that new functionality. So rather than creating, say, like an API or a library that does this, which would potentially have some overhead based on a given application. We instead essentially extend the language implementation at the lower level to provide that functionality and at a more efficient level, so that the higher level pieces that uses it don't have to worry about any sort of maybe potential runtime overhead or even additional transformations that could happen in order to provide that new behavior. The example that I'm going to go through is a fairly contrived example, but it was an example that was in the book that introduced this that I think is good for us to at least understand. There are three approaches to actually leveraging this. I'm going to write these three approaches down. The three steps in actually leveraging these pieces of functionality are the following. And let me see if I can actually bring this up. Hold on. First, what we do is we define a specialized Metaobject class. Now, what is that? Excuse me. A specialized Metaobject class is nothing more than a subclass of the standard class Metaobject classes. Now, I'm using the terminology that the book uses specifically because historically, the Common Lisp Metaobject protocol, when it was designed, used the term metaclasses, but the authors seem to have gone away from using that term. So if you read the book, especially, they use class Metaobject class to and standard class Metaobject class to refer to these portions of the Metaobject protocol that provide this base interface classes that you would use to subclass and create this extended functionality. So what are those three classes? that we could subclass from. These are standard class, standard generic function, and standard method. For the time being, these are the three that we'll be focusing on. I believe there might be other ones that are also in the actual Metaobject protocol for class. When we go through chapter 5 and 6 in the book, which actually is the main MOP specification for class, and I mean for Common Lisp, we'll address some of those and introduce those additional classes. But for the time being, for the sake of this chapter, these three are the ones that we're going to go through. After we do that, what we do is we essentially override the methods that are provided in the Metaobject protocol that we need to override in order to provide the extended functionality. So this is really just a meaning we're defining methods on the generic functions specialized to this new Metaobject class to provide the extended functionality. This then in turn integrates your Metaobject class into the rest of the system. Then once you've done that, it's really nothing more than making instances now of this new Metaobject class. And we'll show how you would leverage that too as well. And what they call your new user-defined Metaobject classes in the book is it's called a specialized Metaobject class. Nothing spectacular here, but I thought I'd at least mention what the terminology is for folks who are going to be looking at this and referring to the book in other aspects. So that's all there is to it for this. We'll go through some examples, but really the intercessory protocols that we're going to be talking about provide the machinery to allow us to do these three steps, which is create a new Metaobject class that will provide specialized functionality. It allows us to integrate that Metaobject class into the rest of the Common Lisp system very, very seamlessly. And we could then just directly use it. One of the things that for the keen eye to notice here is we are doing nothing different than defining user-defined classes. They're the same approach. You're not actually doing anything brand new. You're not leveraging any of the lower level system APIs. All you're doing is just literally doing what you would normally do if you wanted to, say in other languages, subclass an interface and implement an interface, or subclass a standard concrete class and to provide a more specialized version of that base class. Now, one thing to note here is the implication of what these classes are. These are classes that I would say are more like abstract classes, meaning that their purpose is for you to subclass them or use them as part of the meta class object, which we'll be talking about in a little bit when we go through an example. But you shouldn't actually try to create concrete instances of them by using make instance or initialize, or try to use actually it's just using make instance to create the objects themselves, mainly because there isn't going to be anything that you can actually do with them. Their purpose is to provide extension functionalities. In many ways, and I want to bring this up as a topic of discussion, it seems to me that it's almost as if some of these meta-object classes, these specialized meta-object classes are like a form of a mix-in. They're providing additional functionality to the base classes that are implementing them. But I think that's something that we will discuss as we are implementing a simple example. Now, are there questions about this? Really, this is pretty straightforward. I didn't think, but I thought that this should be at least spelled out before we start going through some examples. Okay. 1 second here. Just want to make sure that I have forgot to pull up the stream. All right. And feel free to interrupt me as we go through examples. And if you have other questions as well, we could address them here too. Forgive me. I have a lingering cough that still won't go away. So let's get started here with a simple example. Now, again, I'm using CloserMop to illustrate this just because although we haven't actually brought up the full CL Metaobject protocol yet, again, like I said, it's going to be discussed more in Chapter 5 and Chapter 6. I want to at least introduce portions of it that we can use immediately, just so that you don't have to go and reinvent the wheel. For folks who are implementing Closette, Closette takes a different approach than the one that CloserMop provides. CloserMop is more fuller functionality. It actually implements the actual MOP specification. Closette is a subset of CLOS. And I think it implements the MOP specification completely, but it takes some liberties that are, from what I can tell, unless you actually implement the full Closette version, you won't have that functionality available to you in standard Common Lisp, which I learned the hard way the other day, which is what I'm going to be showing in this example. So the first simple example of using the MOP and extending the language that I think we can actually cover here is let's say that you want to create a standard meta class, a specialized meta object class that when you use in other classes or you define other classes that uses this meta class, it counts the number of instances that particular class is being instantiated with. So, this is a very simple example. All it is incrementing a counter, as you can see here. The way you would first do it here is you first define your specialized meta object class here, which, as you can see, is nothing more than using def class. You're subclassing from C2MOP standard class, and all we're doing is we're extending whatever the base class that concrete classes that this meta class is going to be used on by adding a counter into them. Nothing special. This is kind of standard. Okay. Now, to use this class in standard Common Lisp as a meta class, you have to, on top of your your subclasses that you're creating, and forgive me, let me just go ahead and pull up the 2D point example that I created the other day. Make sure that this is alongside of here, just so that we could see these side by side. Okay. We have a base class here that we created that just creates 2D points, but now we want to count the number of times every time we instantiate a 2D point. Well, then we can create this new class called counted 2D point that subclasses from 2D point. So it should get all the functionality of 2D point. It will inherit all the functionality of 2D point. Has no additional slots, but it's leveraging the counted class meta class. Now, this, in and of itself, should basically tell your Common Lisp image that this class now has the same semantics as standard class, but in addition, it now has this counter variable that we'd want to use in certain situations. Okay. Now, when you're creating instances, how do you use this counter variable? Well, one way of using it, and this is kind of the approach that I was using the example, which is why I'm leveraging this, is creating an after method that's specialized on the counted 2D point. So what that does is um, it all it does is internally it uses slot value, because notice in our counter definition we didn't actually create an accessor for this, so it's internal. So in order to actually access the value itself, we use slot value to actually grab it, and all we're doing is incrementing the counter. Now, for folks who are reading the book, the original implementation of this in the book was this, and I'm going to show both situations, and this is going to introduce the first error that I got when I encountered this, and I was hoping we can debug this to use the closure mop code. Why is that? Give me
missing a paren on the class.
On the class.
Yeah,
oh, thank you.
Yeah.
Thanks. Sorry. This is correct. I was doing this in the wrong case. There we go. That's it. Again, ignore init args, and I think it was just doing increment f, slot value counted 2D point, because usually increment f is actually a set f on the 1+. So we could simply do this, but in both situations, I noticed that there was a problem. This is the original code. I was trying to debug this the other day because it's kind of weird of what happens when you try to instantiate this. So let me go ahead and comment this out. Okay, and let's go ahead and use this guy instead. Make sure that I got everything in here. Okay, so we've defined this, and we've defined our classes. How do we use this? Well, if you look at the example on how we leverage this, is we could first do slot. Oh, sorry, I have to go into my REPL here. We could do slot value, find class, counted 2D point, counter. We see that it's 0. Now, when we try to make instance of counted rectangle, counted 2D point, and we, instantiate it with some init args, we see the first error that I was seeing here. Now, I don't entirely understand what this is going through, and Elijah, I'm hoping that you can, help me on this. But it says that there's no standard generic function global counter 1 on counted 2D point. But counted 2D points meta class is counter, right? So I'm wondering, is there something that I'm missing in implementing this that is preventing the reader to recognize that the meta class itself?
Can I see the method?
Yeah, sure.
Aren't you missing an accessor for that that slot?
You don't need an accessor in the slot if you're using slot value, right? I mean,
shouldn't matter. Well, so okay. All right. So
I mean, I could restart my image
Okay,
and show you.
so yeah, no, I see. So firstly, you're trying to access the slot value of a symbol.
Oh, thank you.
Hello? There we are. Okay,
Hello?
I can see again.
Sorry, folks. We're having just some technical difficulties. So, give me a second here.
Okay, I think the stream's back for me.
Okay, sweet. Yeah, and I see the stream's back on the
Yeah.
YouTube live too as well.
Yeah, your connection looks pretty bad right now.
My connection shouldn't be that bad, but we will see. Man,
Yeah, for me, your connection is listed as poor.
really?
You're getting a bit rate in the 40.
All right. How's that for folks?
Well, now I can see your face.
Yes.
Oh, there we are. Okay, so I'm seeing. Okay, yeah, you're getting back into the 100 kilobit range for up.
Yes. I think there was a problem with the when it went out temporarily. Jitsi, the Chrome extension, was giving me some technical problems, so I had to refresh the entire meeting in order to force the plugin to actually do its thing.
That's unfortunate.
Yeah.
Anyway, so a couple issues.
Okay.
With your code here. Firstly, yeah, you don't have a validate superclass method, so you will never be able to instantiate into that class.
Okay.
But more generally, that make instance there, the way your specializer is set up, you're specializing whenever the class argument is an instance of counted 2D point.
Right.
Which is a problem because you don't have an instance of counted 2D point yet because you're still making one.
Okay.
Does that make sense?
Okay. Yeah, that does make sense. But that means that
specializing counted 2D point.
It's supposed to be counted class.
Yeah, you actually want counted class as your specializer there.
Counted class. Did I mess that up? Probably. Let's see.
Or
here.
you could do an EQL specializer on counted 2D point.
Yes, you're right. It is counted class. Got it. All right. All right. At least we have established that this was a coding error.
And now you don't need to do the find class stuff because you can just pass class there.
Yes.
Because you actually want the slot value of the class.
Right. Okay.
There you go.
Got it.
And now everything makes sense. Restart your image again.
Yeah, that's probably
You've got some extra methods in there that you don't want.
Okay. It still says. Oh, I still have to write the. That's right. I still have to write that.
You still don't have a validate superclasses method.
Yeah.
Right.
Yeah, I do.
Yeah.
I can write that. That's a very quick thing. But although it was kind of odd when I. Okay, so we need to add validate superclass, and that's a def method. C2 mop validate superclass, and then what was it? Class is specialized on counted
class. Yep.
And
superclass is specialized on standard class.
And
now
body. Yeah, that's it. Okay.
Oh wait, no, your parents are wrong. You've got an extra pair of parents, or you're missing close parent. That's the issue.
Yeah, that's what the issue is. I'm missing a close parent. Okay. That's it. All right. So now this should all work. Okay. Let's see here. We do counter. What? Oh, there's no. Oh,
you need to make it.
Restart my image.
Yeah, load the code and then.
Right. Let me do this one more time because I have some garbage stuff in there. All right. Now I can do this. SS. And go up to make instance of counted to the point. And that's chord. Y chord. And boom. Okay. So we need to. So I just learned something here. I have to actually pay more attention to when I'm copying code from a book. So let's go through this example one more time. So we created a specialized Metaobject class. In this case, when you're specializing from standard class, this is just for folks who are using the closure map. Closat doesn't, I think, require this. And this is probably why I was having some complaints about this validate superclass the first time I tried doing this. This is a method that you need to specialize on the specialized meta object class that you created, and its superclass. Now, in this case, we just returned T. I'm guessing what you'd really have to do is just do a validate, like a find inside.
Actually, in general, most of the time, methods on validate superclass just return T.
Really?
Yeah.
But wouldn't you want to check to make sure that the superclass that you passed in is
so in some cases, yes. You might be defining a custom meta class where the allowed superclasses that aren't instances of your meta class is more constrained than just any standard class. That does happen, but in a lot of cases, when you're defining a custom meta class, you want instances of your custom meta class to be able to subclass from anything in standard class because it's actually completely compatible with standard class. And in that case, you just use T.
Just use T. Okay, so in this particular specialization, just go ahead and use T. But if any other case where you're trying to do a generic thing, it might be. Well,
yeah, I mean, in a lot of cases, when you're writing a custom meta class, you want instances of that custom meta class to be able to inherit from any standard class. That actually is a fairly common use case.
Okay.
Right, like because fairly often you're just trying to add something to your meta class, and you still want to be able to reuse any standard class machinery.
Right. That makes and that makes perfect sense. That's actually one of the reasons why I wanted to make sure when I did this, I threw T in there, but I was like, I don't know if this is a dirty hack
Nope.
or I'm just I'm doing what's supposed to be done
Yep,
because
that's pretty standard. Is putting T there.
okay.
So like there are cases where you're defining a meta class where you want very specific control over the hierarchy. Like you're defining basically your own little tree of classes, and you don't want interference from standard class on there. And in
Mhm.
that case, you'll probably have some very specific standard class, which will be sort of the root of your new tree, and you'll declare that the only valid superclass that's not an instance of your meta class is that one specific standard class. That's another pretty common one.
Where you're basically excluding one specific meta class, but every other place.
Well, you're saying that like let's say you're defining an entity component system,
Right.
right? And you want all entity classes to have a specific meta class. And
Right.
you don't want to be able to inherit from any random standard class into one of your entity classes because you don't know what kind of weird extra nonsense that could bring into the system. But you still need all of your classes to inherit from something. This is one of the rules of how class works, right?
Right.
And so you need some class for all of your special entity classes to inherit from. And so you declare some primitive entity standard class. And it
Mhm.
has to be a standard class because your meta class doesn't exist yet. And you then you add a method on validate superclass, which says that your entities that are instances of your entity class, they can't subclass from any old standard class, but they are allowed to subclass from the entity standard class, right?
Right.
And now and now you have a valid superclass that you can subclass in all of your classes. Sort of the way that every standard class is a subclass of standard object, right? You
Right.
now have a standard parent class that you get to use. Really, the problem is that you can't replicate standard object, right? Standard object is special. Standard object is an instance of standard class, but standard class is also a subclass of standard object. There's a weird circularity there that you can't replicate. There's bootstrapping nonsense that you need internals to get into. And so since every class needs to subclass from some other class, you can't replicate the primitiveness of standard object.
Right.
You have to create some standard class, which your special classes are allowed to inherit from, to give
Right.
them somewhere in the tree to root themselves.
Right.
Right.
And that's also why they don't allow say for example you to go and replace the entire root object hierarchy. You're almost always restricted to subclassing standard class. You're only you can't go and change like T for example because
Correct.
The garbage collector it will throw up and complain and
Oh, yeah.
other problems could ensue.
Oh yeah.
So
Well, yeah. The class machinery isn't built to handle those kinds of classes.
right, which brings up a topic that this example kind of went into as to one of the use cases, and it brought up something that we didn't really like dig into in details, but I think we have an opportunity to. So just to give other people, some context, one of the nice things about this sort of subclassing of standard class is that you can now change behaviors of how, for example, inheritance works, but at the lower levels of the object hierarchy, you're still technically all subclassing from the root object, which again, like we just talked about, gives you access to the lower level machinery for memory allocation. It's how the garbage collector recognizes your objects and so forth. Example that was in the book that I thought was pretty interesting was how they use this machinery to implement the flavors, loops, inheritance stuff. But they brought up one specific thing in here that I wanted to bring up. because it's related to the full class, which is using this scheme to create a variant of class in which the class precedence lists change frequently throughout the program's execution. But it might be powerful, but such a behavior would affect too many other parts of the language, and they explicitly call out change class on this. In this case, like they're like, what, for example, should instances, if the change to the class precedent has caused slots to be defined in the class to change, or what would happen while a method is rushing and a class precedent lists changes in a way that affects the sequences of next methods. Now, change class doesn't have that ability to do that, does it? Like, I didn't think that it's possible for you to use change class to change the method call chain because
what else could happen if you change the class of an instance?
I thought change class only changes the representation, because don't you have to override the redefined methods and recompute all your what is it? You're taking existing slots and you're recomputing how those slots would work with the new accessors. So change class essentially is changing the underlying representation of it, but it's not necessarily changing standard method combination, right? It's not changing.
Right. Yeah, but what methods are applicable now changes, because it's an instance of a different class.
Oh, but when I hear next methods, I'm thinking specifically method combination.
Correct.
And
but method combination happens after you've computed what methods are applicable.
Yeah, and that stuff is tied to the class,
right.
not to your object, right? So when you switch the class, all those methods are defined on the class that you're now pointing to. Not, it has nothing to do with your object instance.
Right. Okay. That's right. And that's what compute applicable methods uses. Yep. So you're essentially saying that by using change class, you essentially re-triggered computing your effective slot definitions, which changes your
well, not just that. Like so like if I change class in the middle of a method that's specialized on that object that I'm changing the class of, right? And then I call next method, right? What next method should it call? Should it call the next method for the new class of that object? Or should it call the next method that was next in line given the original class of that object?
Right. That makes sense.
And neither answer is good, basically, because if you say that it should call the next method, relative to that object, what is that next method, right? Like, does it restart the entire generic method? Does it basically recall the entire generic function? What is the next method now that you've changed the class?
Right. Okay.
And if it calls the next method of the original class, well, that new method isn't built to handle instances of this different class.
Okay, so this is only in the situation maybe if the method has the same name. But because if it's a new API, you have to compute the method call chain anyway, so it doesn't apply there.
If you call a different generic function, then you're good.
Yes. But
if you use call next method, there is no sane next method to call.
Right.
Right.
Right. Right.
The problem is that change class happens in place.
It happens in place.
Yes.
It doesn't copy the class and then do it. Oh.
Change class happens in place on an instance. It changes the class of the instance.
Oh, that.
Change class doesn't mutate a class. It changes the class of an instance.
Yeah, it keeps the same pointer reference.
Yeah. Keep the same pointer reference and changes the internal representation. That's a little dangerous.
Of the instance.
Of the instance, yeah.
Yep.
That's weird. Okay, I didn't know that.
You can assign to the class pointer in a Python instance. Same idea.
You can assign to a pointer in a Python
You can
instance.
assign to the class pointer of a Python instance.
Interesting. I did not
Fun
know
fact,
that either.
you can assign to the class pointer of a Python instance.
Good.
And Python handles it a lot less gracefully than Common Lisp's change class.
Wow. That's good to know, man.
Oh,
By
yeah.
the way, since we're on the topic, what is a good use case for change class?
Well, so that's a complicated question.
Is it like more of a tool, like a tooling kind of thing? Like, you'd use it like
Yes.
in a GUI creator or something like that?
Sure, that is one. So in my opinion, change class is something that you have to design your API to make useful. Change class can be useful if you design your API in a way that makes an operation like that something that's useful to have. But most APIs that we're used to designing aren't designed to make use of an operation like that. And so it's difficult to talk about like use cases for change class because they don't really exist if you haven't designed your framework to be a framework where changing the class of an instance is a well-defined and useful operation.
So I can at least think of one use case just because I know folks who have designed this, and they almost always end up recreating this. So it's always nice to have this kind of machinery, and that is in when you're designing like a level editor for a video game, and you're trying to change the representation of your classes and different properties of it. A GUI editor, like you mentioned, Michael, is another good example. Just because, again, in there, you're not entirely sure how something is represented underneath until you've gone in and really instantiated it, right?
So on a similar line of reasoning, there's one way of implementing something analogous to an entity component system using class is to use the Metaobject protocol to create classes that mix together your entity classes, right? And then use change class whenever you want to add or remove a component from, your component classes that mix together your component classes. And then use change class whenever you want to add or remove a component. So you use make instance of standard class to make a standard class that subclasses all of the component classes you care about. And then you instantiate that. Now you have an entity which has all of those components. And then if you want to add an additional component, you make a new class which subclasses all of the components that the previous class did, but also subclasses this new component. And then you change class on the existing entity, and that adds in this new component.
Gotcha.
Right, and so that's one way of making use of it. But that's a particularly hairy use case because you have to have designed your whole framework around the idea that changing classes is a well-defined and meaningful and useful operation.
Right, you have to have a real good reason.
I don't think it's so much having a good reason to do it. I think it's just that you have to decide up front that the mechanism by which I'm going to implement this particular dynamic change in my system is going to be via class changing.
Right. So let me rephrase that. You have to be cognizant that in your system design that you are agreeing to this use case of where your objects may have potentially different representations that can be changed dynamically at runtime, right? You're basically making it clear that your system, there is no, you have to use introspection as an inherent way of leveraging and figuring out what the state of your system is, right?
I mean, method dispatch, but yes.
And I think that's a very good design goal that that needs to be stated up front, like you said. and it'll then make things like change class to be pretty useful. But the danger for me, at least, and this is a concern that I didn't think about until you mentioned about the in-place replacement, is and this is kind of going a little bit into the weeds and probably is an implementation issue, is change class could be changing the representation of a class whose size, the metadata size, is different than
Yes.
that issue. And if you're doing it in place,
Mhm.
could it be possible for you to trample over
Implementations have to be designed specifically to account for that case.
all right.
The short answer is it will never cause problems for you, but imagine how much more difficult that makes implementing standard object.
Right.
The class set
So the-
implementation was pretty easy because they just used lists and they just replaced all the lists.
Right, yeah, that's one way of doing it. Is really the answer is that what that means is there has to be a level of indirection between an object and its slots, so that you can change out the storage for the slots without changing the identity of the object.
The solution
think-
to every problem in computer science.
Oh yeah, just add another level of indirection. Does that make sense though?
Yes, that makes sense. It's a very very implementation specific
Yep.
issue.
Somewhere in there, every standard object has to have an extra level of indirection between it and its slots. Somewhere. Exactly what that extra level of indirection looks like, very implementation dependent, but they all must have one, because otherwise you're right, they cannot be changing the storage without causing allocation problems. Now it's possible that the way that they actually do this is by leveraging some feature of their system that allows them to relocate an object without changing its identity. And that would require some interesting and funky features of their memory management,
Mm-hmm.
right?
Right.
That would be one way to do it, is you relocate that object to somewhere it has more space.
But the relocation is all automatically a new allocation, right? You're not changing
Correct.
it. You're no longer changing it in place, right?
Well, you're changing it without changing the identity of the object.
It still has to be EQ to the old one.
Mm-hmm. Still has to be EQ. That's the requirement. The requirement is that it's still EQ to the old one. It's that any existing references to the object now point at an object that class is different.
Right. Externally, it's still EQ because it's still pointing to the same identity. It's still pointing to the same object. But internally, it technically isn't, right? Because you're looking at a new memory location. You're looking at a brand
It
new.
depends what you mean by identity.
Yes. Now we're going full meta.
It depends on what you mean by identity.
Well, so like is the identity of an object the storage location of its slots?
I would think so.
Kloss disagrees.
All right. That I just learned another thing about class today that I didn't think about. All right. That's
Because otherwise you can't change class and have it, maintain identity. Because you're right, the storage for the slots has to change when you change class, but the identity doesn't.
So EQ really means.
To be honest, that's right. I'm sorry, I was going to say something, but never mind.
So EQ really means you're looking at the contents, the memory contents. You're not even thinking about where something is pointed, because it allows flexibility for the implementation to do the right thing and provide some guarantees about your object.
EQ means that there is no function inside of Common Lisp that will distinguish between these two things.
Right.
That's all EQ means. EQ means that there does not exist any function. If EQ returns true, there does not exist any function defined by the spec that will distinguish between these two things.
And how is that different than EQL and equal again?
EQL, so EQ isn't guaranteed to return true for numbers with the same value.
Okay.
EQ is like if you look at it from the Java perspective, EQ is like the double equal on pointers, right? So it's essentially for most implementations.
Yeah, for most implementations. But my point is that looking at it that way can be a little misleading when you start thinking about that means that it must be the storage.
Right.
Right.
You see, Michael, your definition of EQ is what I was thinking, pointer comparison. But according to the change class use case, that's not the case. That can't.
So on a lot of implementations, EQ is a pointer comparison, but it's a pointer comparison of a header. It's not a pointer comparison of the storage for the slots.
Okay.
That header contains in it another pointer to where the slots actually are.
So it's every level of indirection. Okay, so that makes more sense. So basically, you have
on a lot of implementations.
Okay.
Not all
when you
implementations are like
when you
that.
create an instance of a class, you know that little number after it in the printed representation?
Yeah.
That's the SAP and SBCL. It's basically a pointer.
Yeah.
And even if you don't change class or you don't do anything, that pointer can change by the garbage collector at any moment.
Because the garbage collector moves stuff around.
Right, and that makes sense.
It just also guarantees that all of the existing references to that thing get updated.
But you can still use EQ at any time to refer to that object. And compare identity, they call it. But the storage can change at any time.
Yep.
Yeah, but what you're essentially EQing is the metadata. You're not technically EQing the internals of the object itself.
You're EQing the
hold on.
pointer to the object.
Put yourself on mute, please.
I can mute him. Or it's possible that we all have to mute him. Oh, there we are. Mute. There we are. Sorry, Judd, but but yeah. So you are EQing the pointer, though.
You're EQing the pointer to the metadata. You're not EQing the pointer to the internal the object contents, because that's EQ. That's another level. That's EQL. That's where you're now looking at another layer of equality. You're not actually looking at what EQ is actually doing, right? So this is a bit of a confusion here, but it's related to this notion of what class precedence is and how the Metaobject protocol kind of works, and at least for this particular use case of let's say that you wanted to create different parent hierarchies, or you're trying to change class, or you're trying to do stuff. So that's why I'm trying to clear this kind of thing up, at least for me, because
it's a similar idea to what about a resizable vector, right? An adjustable array.
Right.
The adjusting the size of the array happens in place.
Right.
If it's adjustable.
Right.
But that still has to be a new allocation of something.
It is a new allocation to the outside, and the equality comes from looking at the higher level object. But internally, you're right. The actual location of the contents could change.
Right.
Well,
might have to.
Yeah, it will have to. It will have to. Right.
Might have to. Probably has to.
In the case of a full array where you're forced to do a doubling of the entire array, or you're resizing it, you will probably
has to.
Yeah. Okay, that makes sense.
Same thing. So it's similar with slots. Similar with standard objects.
Right. Okay.
You can think about them as implemented by.
right? Because even if the like Mike was saying, even if the ID of the quote unquote pointer changes, right, inside the garbage collector, if you have a migrating garbage collector like that, there's some other level of indirection in the garbage collector that tells you I move this thing from this heap over here to this thing heap over there.
Right.
So even in that sense, it's really the same thing.
Can you say that again, Michael?
Right.
Yep.
I'm sorry.
Identity can.
Yeah, I was just saying that, like, even in the sense that you were saying with identity, and that that quote unquote pointer can change. I'm saying, like, if you had like a migrating garbage collector, even though the thing is moving your allocation from one heap to like another heap when it's compacting it or whatever, there's still some level of indirection in there that says, like, this is the same thing. I just moved it from this heap over here to this heap over there.
Oh, absolutely.
That's the thing you're EQing.
Right.
So, I mean, the easiest way to think about it is just like a pointer in memory, even if it's not exactly,
Right.
The only thing that's probably not
memory.
changing storage identity is a symbol.
Yeah.
It's part of the parser. It's in a lookup table. It's
right, and that makes sense. So we've kind of beaten this to this provides context into this next thing that's in the Metaobject protocol that I thought was really interesting to implement some of this.
I'm sorry. One other quick question, Ram, before we move off this. I just wanted to know if anybody had an idea. Is there a reason to ever define a meta class to do something like this, where you have like where you're just adding a slot versus using like just a class slot?
Are you talking about class variable versus using this meta class where you're adding?
Right.
Okay.
Well, so a class allocation slot, right, is allocated yeah, let me think about that. Yeah, so in this particular case, I don't think we've done anything that's different from just using a class allocation slot, apart from the fact that it's sort of it's easier to abstract away, I guess.
Okay. Yeah, I mean, you can have multiple, right? You have multiple things that have this thing by just using the meta class tag instead of having to include it in every one of those other classes. And I'm also assuming that this is like pretty much the standard way in Lisp of handling singletons, something like this.
That's a pretty I mean, I haven't actually seen a whole lot of singletons in Lisp personally, but it is a pretty good way of doing it. Actually, the more standard way of handling singletons in my experience is using something involving a dynamic variable. But
okay, yeah, that makes sense.
I guess the other thing is that this is actually a slot on the class, whereas a class allocation instance slot or a class allocation slot is still accessed on the instances. It's not accessed on the class. Like if you make a slot with allocation class, you still access it via one of the instances. It's still a slot of the instance. It's just only allocated once per class.
Say that one more time.
A slot with class allocation, right? If you have a slot on your class where you give the allocation class slot option, right? You still access that slot via instances of that class. It's still a slot of the instances. It's just only allocated once per class, and it's shared between all of those instances.
So each instance will have a pointer to the class variable.
Something along those lines.
It's not accessible via the meta class then.
It's not accessible via the class object.
Yeah, well, if you're using the meta class, though, It
Yeah.
um,
Whereas that actually puts a slot on the class object.
right. So it's only accessible through the class object. It's not accessible through the instances.
Yep.
Which means you have a true. I would say that in this particular example, with respect to class, you have a true class variable in this case because the only way to access it is by accessing the class.
Yep. Whereas slot allocation whereas class allocated slots are really better thought of as slots that are shared between the instance. They aren't really best thought of as slots on the class. They're slots on the instances that happen to be shared between all the instances.
So what would happen with change class in that regard?
Change class still treats a slot allocated a slot with allocation class as an instance slot, and it gets the value as if it were any other instance slot. Yeah.
That's one thing I haven't really found a good use for in Common Lisp yet is class allocated slots. But whatever.
Well,
Yeah,
I would think that if you're using slots with allocation class, which is a shared variable, you're incurring, albeit a very, very small memory overhead, a pointer addition to your storage, your
Nope, you're
object storage. You're not?
You're not.
I mean,
Nope.
wouldn't you would have to keep track of on each instance?
It can store it can put the actual storage for a class allocated slot on the class and reuse the class pointer that's in the object.
Oh, okay. So you don't even have to even do that. Okay, that's nice.
It
All right.
already has a pointer to the class. It has to.
Right. Well, it does. It's just that I thought that you would create new pointer aliases essentially to that location rather than just sharing the pointer. But if that's what they're doing, then that's what they're doing. You know that makes
Well, I mean, implementations are free to do whatever they want. I'm just saying that there's no reason why it would need to have an extra pointer just to store that.
true.
There is no requirement that every instance slot actually incurs storage on the instance. This is actually something that's reflected in the Metaobject protocol in a few places. There's no requirement that a slot, an instance slot, actually means there's extra storage on that instance. When you have an instance allocated slot, then yes, you are guaranteed to have additional storage on the instance. But there's no guarantee that a slot is allocated as an instance allocated slot, right? That's the reason why the allocation option exists. And so just because you have a slot doesn't mean that you're gonna change. So there's what standard instance access. I forget the function. There's the function that's the primitive for accessing the slots that are actually allocated on an instance by number. And that only accesses the slots that are allocated on the instance, as far as I know.
You're not talking about class slots. You're talking about something else, right?
Yeah, no, standard instance access, I think.
Okay.
It's the primitive for actually accessing a field on the instance.
Okay.
And it takes a slot number.
Interesting.
And it takes an instance and a slot number, and it actually goes and looks in the storage of that instance and pulls out the thing at that offset.
That would imply that if you have a slot number, that you're using some sort of vector or even list for accessing.
It would suggest that, but it doesn't require
it. Interesting.
This stuff makes my head spin when I just think about how threading and this stuff all interact together.
Right. I'm sure you could totally use this to create, like, one thing I was thinking about, like, associated with the counted example. I was like, so for immutability, I could just create a class, that's some class of standard class for immutable, just say turn this flag on and then have a method that if this is an immutable class, just throw in an error. You can't modify any of your slots, right? You can essentially, you could just say.
Nothing stops you from doing that. Sure.
So you can.
I don't know if it'd really be useful. You wouldn't get a whole lot out of it other than the, I guess, correctness guarantees. You wouldn't get any. It wouldn't operate like something that's designed to take advantage of immutability would.
Right. True. But what will enable you to do, at least with respect to Common Lisp, is you could leverage that in say a compiler macro to write optimized code, knowing fully well that what's being passed in the parse tree are all immutable objects, right?
Sure.
So it allows you to extend essentially the compiler more reliably, I would guess, in this case, because you have some a priori information about the state that's being passed into the optimization stages. But that's the only reason why I was thinking about it. I was just like, this enables you to do some interesting things.
Yeah, sure.
So the one thing that I wanted to bring up when I brought up change class was they introduced this particular use case of flavors, loops, and class to introduce the portion of the Metaobject protocol that computes class precedence lists. And there were some rules on specifically when you're implementing this class precedence list that I wanted to kind of bring up and sort of emphasize. There are three things. One is the class precedence list. I'm sorry, folks, is a fixed property. You can't once it's computed, it doesn't change. It includes all the classes' superclasses, and you must include in those superclasses standard object and key in that order. So what that means is and the example that they gave here for I'm just going to go ahead and write this example here because it's a pretty simple one. Let's say that you have a class A and a class B. I think we went through some similar example like this in the past, but I'm going to show you the order in which some of this can be computed here. So let's say that you have then class C, and then let's say that you have a class D that inherits from A and B, and then let's go ahead and create a class E that inherits from C, and then class F. Oops, spelled that class wrong here. That inherits from, let's say, B and E. Right? So let's compile this. Hopefully I didn't create any cycles in this. I don't think I did. All right, cool. So the order in which class actually computes the inheritance ordering, the class precedence that is using topological sort, if I'm not mistaken. It essentially creates a graph of this and then creates does a topological sort to return you, like if you wanted to find out what the inheritance is of class F, we start with D and E, and then we go up there to the common base class between D and E, which is A. Then we look at again left to right. I think it was right to left associative. So after that, we'd go up to, I think it's C for this, then B, then we have our
I
right?
think it's actually BC. I think it's ABC.
Okay.
Make instance F.
Yep, we're gonna go make instance F here.
I think it's BC.
Let's see. Make instance F. All right. And go here.
Click on the
Hit on the class.
So here in the class precedence
Oh
list.
no, FDEACB. Yeah, you were right.
What the hell? What's slot object?
That's a primitive in SBCL.
Oh, okay.
Don't worry about it. It's an implementation detail.
All right.
You were right though. It's BC or CB.
CB. So this is CB. Now, what's important about this is when you're computing the class precedence list, because the class precedence list computation is a generic function. The requirement by the Metaobject protocol, and this is a requirement for class especially. This is not for folks designing their own Metaobject protocols. Is something that you need to be aware of, but certainly for class it's important. Is that when you're computing the class precedence list in your implementation, the ordering in between the most specific, that is the class that you're declaring at the time, and standard object could change. But in the beginning of your list, the precedence that's always true is F must be in the beginning of the list. And at the end of the list, in this order, standard object and T must be at the end. That is a requirement. You cannot change it. It's undefined behavior, I think, is what they said in the book. If you go and try and do that, so really, depending upon which implementation you're in, you might get a different bug. So just do not try to change the ordering of this requirement, which is always keep. I'm going to go ahead and write this down for folks, which is when computing the class precedence list, always keep the class that is being declared has the most specific class in the beginning of the list. And always specify standard object and T at the end of the list in that order. Now, most of the standard object and T arguments is really related to, again, what we were mentioning earlier about how the garbage collector recognizes your objects, how some aspects of the machinery recognizes your objects, and more importantly, how it will integrate with some of the standard OO machinery that's available in CLOS. So you're free. You're more than your freedom is only between in the case of this F example here is this computing this list and the precedence of the list of the superclasses between F and standard object. I was a little when I first read this, I was a little surprised, but it made sense when he started going into why that is the case. So I'm going to pause here for a second to see if there are questions on this. I mean, it's just a requirement on when you're defining your own special meta object classes, how you'd want to compute this stuff. But are there questions on this? Cool. All right. I could go through. Sorry. I could go through implementing flavors and loops if folks are interested. But it looks like we're heading into the last 10 minutes of our session. But if you guys are willing to go over, we could totally continue going on with the rest of chapter 3, which is a bunch of case studies. The second example here is a fairly involved example, but I think it's a really useful one to go through, which is slot inheritance, and it goes through an example of something that I was thinking about from Clojure, actually. So Clojure has this this meta class when you define this meta key word when you're defining classes that allows you to provide metadata for, I think it's called meta, or it's like metadata, where you could tag like a hash map essentially internally with additional information about that class. And the example in the Metaobject protocol is exactly that for slot inheritance, which is you could provide like, different types of attributes on a slot and provide, accessors so you can internally mess with the metadata. But behind the scenes, I mean, in terms of the higher level machinery, you can access the slot directly, or you can access the slot attributes directly. This is a fairly involved example. If you guys don't have the time to go through this, certainly we can stop here and touch base next week on it. But I'm opening it up to the floor on suggestions. Anybody unavailable? All right. So I'm going to show the the background, I guess. Let's see if I can get this in. Let's see here. So the example that was in the book that I thought we can leverage. I'm going to just go ahead, say refer to chapter 3 of AMOP for more information. That I think we could do something similar is this really something called, let's say that you're building a banking application and you are, leveraging, you're trying to, verify that, for example, that for a given, individual, that their credit rating, that you have some information about when a slot was set. Like, for example, let's say the credit level of the application that you might have. And the idea is you could specify these attributes of when it was set in terms of its date and its time. Okay, so this is the core piece of this class. Well, you can't just, define this class this way. You have to specify a new class called attributes class, right? And I was hoping that we can go through the example of, well, how would one actually add such a class to provide metadata to each individual slot? There is an approach that's specified in the book, but I thought it would be much cooler for us to, try to figure out how to do this ourselves. But to introduce this, I need to introduce two specific things, and mainly it's related to, and this is in addition to some other portions of the Metaobject protocol that will be introduced as we go through and implement this. One is well, what are effective slots, and what does that mean in terms of the meta objects and your classes themselves? So, to begin with, when we start talking about meta objects and classes that use meta objects, when a class gets instantiated, we all know that it goes through, and from earlier discussions, there's a function called ensure class to make sure the class exists, and then it goes and tries and creates an instance. We go and call make instance, and it will go through and compute what your class slots are and what your superclass slots are. The unification of, if I'm understanding this correctly, the union of all the class slots and its superclasses slots are accessible from the subclass. That is your set of effective slots. And this is something that occurs at, I think it was instantiation time. No, I think, it's at the first time that the class is used. After that first time that the class is used, and those slots are computed, they're memoized, they're cached, and they're just retrieved. They're not recomputed again unless you do what we were talking about earlier and use change class. So the two methods for this, for doing this kind of things, are methods for computing slots in the Metaobject protocol is compute slots and something called, I think it's like, compute effective slot definition. Compute slots calls compute effective slot definition, but I'm putting them separately here just because I think that's how it's defined in the AMOP specification. The first thing is what does compute slots do? It actually does nothing more than it gathers all the lists of the class, the direct slot definition meta objects from the classes and superclasses. That's all what compute slots does. But it uses this to pass in as an input to compute meta slot definition to union these guys and create single effective slot definition meta objects that holds the ordering of how to apply each slot, and that's kind of like how when you do call next method, how it determines what the next method in the call chain in terms of specificity to actually go and execute. One question I had is this effective slot definition meta object, is slot definition meta object different than effective slot definition meta object? Like, is there like, and I didn't go, again, this is because I haven't jumped ahead to chapter 5, but I'm guessing that there's some metadata that's different between the two in terms of what's provided.
The effective slot was just the slots throughout the precedent chain, the ones that you inherit, versus the direct slot, which is just the ones that are defined on that class alone.
We saw that last week.
Right.
We saw that last week when we were unable to use an effective slot definition. To gather the slots of a class, we had to traverse through the precedents to be able to call the gatherer function on all the direct slots because we couldn't work directly with the effective slots.
So a slot definition is is the same as a direct slot definition. It's not different. I'm only asking because I was looking at I think it was the hierarchy of stuff, and I noticed that they have a standard slot definition, and then they have a standard direct slot and standard effective slot. And I was kind of curious what those differences were, and I guess it's just they made it a hierarchy so that it's easier to compute the precedence order between direct slots and effective slots. But that's just me getting a better understanding of that piece. So you really are always dealing with effective slot definitions when you guys are calling functions. You guys are never, unless otherwise specified when it comes to and I think the only case that I can think of is accessors or readers and writers. I don't believe that you would ever use when you call a method that's specialized on a class a direct slot definition. You would always be doing an effective slot definition. But that's an implementation detail. Some implementations might implement it differently. I think SBCL does that, at least from after reading this, I'm thinking about all the errors that I've had in the past that I've never quite understood, because now they're making more and more sense as to why they said it's an effective slot definition versus a direct slot definition. So yeah, how would we go and implement this attributes class? Well, first, I think you would just first, let's start, create a class that just subclasses from standard class that I'm guessing internally this would hold the metadata that's being passed in. At least this is how I think we go and implement this. So feel free to come up with some, suggestions on this as I go through this. Let's see here. I don't think there's any. You know what? I don't think we need to actually specify any slots on here. Let's do that. So now, we have to go and compute the slot attributes and compute the effective slot definitions for these two in order to actually use this particular class. So you would then define your def method compute slots that holds, let's see, I think it's yeah, that's specialized on the class. That then you would have a list of, actually, I think I have to specify this has been C2 mob, compute slots. Yeah. And the direct slots associated with this guy. So we're actually going through and holding the values of the attributes. We have to somehow map a list of all these slots into our actual slot definitions. This looks like this is going to take a little bit more time. Hmm. Let's see here. Okay. I think I'm going to have to work through this example a little bit myself, just to make sure I understand this. Um, yeah, this is going to take a little bit more time than what I have allotted for. I'm going to end it here
All right.
for compute slots, just so that I can work through this a little bit more and probably get a more meaningful example. Stay tuned for next week. Any announcements related to other events that are happening? I think related to the Common Lisp Study Group, stay tuned to our Mattermost channel for new announcements on projects and things that are coming up. I'm working on a new website for the Common Lisp Study Group. I'm going to keep you guys posted on that. Folks that are interested in providing feedback, or if not, helping in actually building out the site, let me know on Mattermost. We can try and work together on this. Uh, Also, topics. I know I mentioned this multiple times. Let's try and get some more interesting topics going in. List them on Mattermost, on Discord. I'm available on the Functional Programming Slack channel, and Tech 404 if folks are in the Atlanta area. But other than that, until next week, I'll see you guys soon. See ya.
See you.
I